Hi, so I came across this patent when I was doing some research on the seawater and graphene generator and generally free-flowing liquids when we were looking at carbon conductors, and I loved it because it had all of the qualities that I really like about this stuff. One, it's cheap, it's easy to do, and there's a minimum tool requirement. You'll get away with a hacksaw and a hand drill. What I've got here is a load of 6mm, or if you like 1/4 inch diameter tube. And I've got some aluminium tube and some brass tube, and I just grabbed a few lengths of it to be able to make some of the stuff that's in this patent. And that's what I'm going to do. I'm going to make some of these bits, show you how they respond and how they're made. So let's get on with one of them. Okay, so I took one of these, which is one of those nylon blocks you use for holding kitchen cabinets together, stuck 2 pipes in it and made this. Then I promptly stuck it in some tap water, which is right here, so that's just that, in some tap water. Connected it to my multimeter. Now, according to the patent, these are microamps, which is why I've come to the really quite decent multimeter. And I've put it in series with a 5.1k ohm resistor as a dummy load. And it's doing absolutely jack, which is kind of cool. I mean, we're getting a completely zero reading here. And we should do. If we put it into the tap water and we were getting a reading, it would indicate there was some kind of galvanic corrosion going on. But because we're getting nothing at all, then anything we get after this has got to be, well, reasonably got to be due to what the guy says in his paper. Now, there's a couple of things that he says. The first thing he says is waggle it about a bit. And the next thing he says is heat it. So I've brought my heater stirrer, and I'm going to heat that up to 90 degrees centigrade, and we'll see if we get anything. Okay, this is kind of cool. I was going to give this a while, let that water heat up, but it's just off tepid. I mean, it came out of the tap cold, and I can stick my finger in it, and yeah, that's really quite cool. But those microamps are going up. It's now at 24 microamps as it's gradually heating up. I mean, 24 microamps is not going to charge your mobile phone, okay? But it is super cool getting anything at all out of this. And it looks like the guy was spot on in his patent, and it's got to encourage you to try other things with it because that is actually working. Still going up. Okay, apparently it's all got to do with the movement of the water, or so he says. So I made this one, and if you leave it in there fixed, nothing happens. We heat it up a little bit. The idea is the water is moving and we start generating power. He also gives instructions for making this one. The only difference between this one and this one is I can waggle that a little bit by flipping it backwards and forwards. And that is supposed to also generate. So we're going to take this off the heat, we're going to set this one up, and we're going to give it a bit of a waggle, see what happens. Okay, I'm wearing gloves just to stop me interfering with it, because all I'm doing really is pressing that like that, just to make it wave around a bit. And sure enough, when I waggle that aluminium bar, the generation goes up. And when I stop waggling it, it goes back down again. It's a bit of a delay. I'm guessing it's because there's a mixing going on there. So he talks about downstream and upstream, because the whole idea in the patent is that the fluid moves across these. So it moves in that direction, with the aluminium being downstream, the brass being upstream, and the aluminium is negative and the brass is positive. So I think that's a pretty cool result. And of course the next question is, what are we going to do about it? Because what you do about something like that is you build a big one. So I made 8 of them in a row, and of course you've got to test something like that in the real world. So I've come down to the Stour River. I live near Canterbury, and the Stour is the main river, and it's this sluggish flowing stream that we've got just there. And what I'm going to do is dip this in the stream. Now remember, or if you read the patent, the aluminium is the upstream and the brass is the downstream. So the river's flowing that way. I need to put the aluminium in that way. And I've got it on a 5.1k ohm. I've got a little handheld multimeter here so that we can get some kind of reading out of it. There's the meter. There you go. That's me struggling to reach in. So, that little thing does what it says on the patent. Okay, close up on how this is made. 2 bits of pipe at 6mm outside diameter, 1 aluminium and 1 brass, cut into 8 125mm length tubes. Flatten the ends with a hammer or a vise, and then take one of these. This is from there. It's a whole bag of those nylon corners you get for putting cabinets together. What you then do is take one and put it in there, and the other and put it in there, and make yourself one of these. That is the single unit. It's that easy to make it. And that's the one we did the original test on. What I then did was make 7 more of them because we had 8 rods and a bit of threaded bar. We've got 1 hole left. You stack them up and put the bar through the hole and you get that. So that's how that was made. All I then did was attach wire to those crimped edges to get me my 2 contacts. This one's soldered on because brass and copper solder really nicely, and this one is just hammered flat. I reopened those holes, poked the wire in, hammered it flat again, and that's how I made the generator. Okay, so remember the patent is 4153757. It's William Clark, it's a US patent, and it's from 1979. Now I chose it because I thought it was really easy to replicate with the bare minimum of tools and just a bit of fun to do it. But it looks like Mr. Clark was actually right. His stuff works as advertised on the tin. Now, if you read the patent, please do, you'll find a whole host of drawings and implementations on how that could be possibly used, along with some suggested different materials, and maybe different materials in different orientations where you get size differences. We've actually done some work on this on members channel where we were looking at flow rates past different carbons, and that's what led me to this patent. But there's some drawings on here showing you how you can set that up, including using gelatin. If his claims are to be believed, and to be honest what we've looked at so far certainly backs up what he's saying, he made one with 6 sheets of brass 1 inch by 5 inches all joined together, and he stuck it in some heated water, had enough power to run a 7 transistor radio at full power. And that's kind of really awesome actually. That's a significant amount of power, and I'm probably going to build a replication of that myself because so far my replications of what he's been doing and what he said on there certainly bears up what he's saying. But I thought I'd share it with you because it really is a good bit of fun for something that can be done super easy and is very impressive. Now, this obviously, according to Mr. Clark, and certainly we've got nothing on here, but then we have only just dipped it in once, there is no corrosion on this apparently, so this is Perpetual. Certainly would last an awful long time. Given the arrangements he's talking about, it would put out enough power to run small devices. I think that's actually quite intriguing and certainly worth the effort of looking into further, given that this stuff actually bears up what he's saying. Anyway, I hope you enjoyed the video and thank you very much for watching.